Let me check the microphone first. This is amsterDOT. This is amsterDOT. Okay, it works, I guess. Okay, everybody. Thanks a lot for coming here. My name is Harald Heckmann, or Harald Heckmann, if you pronounce it in German. And yes, I am representing Zeitgeist here as the lead blockchain engineer from Zeitgeist. And I'd like to tell you today what Zeitgeist is actually doing, what's the idea, and give you a little insight into the protocol and what we have already. So, yeah, what's the next slide? Oh, it's here, okay. All right, so, yeah, maybe before we go into the prediction market stuff, the core structure is I will tell you what prediction markets are, and then I'll show you a little bit of the of our blockchain architecture. And then we'll go actually into the automated market maker algorithms that we implemented and use. Yeah, and finally, yeah, there will be some closing words. So, yeah, Zeitgeist is an evolving blockchain for prediction markets and Futarchy. It is built on Substrate and ready for Polkadot. In fact, it's already a parachain on Kusama. So, what you might ask yourself, what is a prediction market? It's exactly what the name says. It's a market that should predict something. And the idea behind this is that data has shown that there's a lot of wisdom in crowd. And the fundamental idea behind the prediction markets is that we want to aggregate this information from the crowds by using markets. So and the idea would be you want to know something like, will an event occur? And then you can create a prediction market on that question, which will have different outcomes, like yes or no or something else. That market can then be traded by anybody. That means they can buy the outcome assets. They can buy or sell them for base currency. The trades will actually change the prices, and the prices are directly proportional to the probability that that event outcome will happen. Yeah, that was prediction markets in a nutshell. Now I'd like to go into more detail in regards to that. So how would it work for you? I just explained it, but yeah, you create your market with the question, then you trade on your beliefs. Everybody trades on their beliefs, so they put their information inside the market, change the probabilities of the outcomes. Eventually the market period is over, somebody reports the outcome, and then eventually the market resolves and everybody can redeem their outcomes. So to give you an example, if the answer is yes and no, and it turned out that the correct outcome was no, then everybody who owned yes will get one of the base currency, like Zeitgeist token, for example, or you lose everything basically. So you better make an informed guess. There are also other outcome types than that. So I'd like to go into the 3 fundamental outcome types that we plan to support. 2 of them are already implemented. The last one is still in the planning. So we have the categorical outcome. This is basically the question, will A, B, or C occur? I will give concrete examples after that slide. Then you have the scalar market. Will the outcome be closer to a minimum or maximum value? And then you have the combinatorial markets. They are basically a combination of the different markets, the different outcomes that can occur. So you could phrase questions like, well, if A happens, will then B happen, right? So to give you some examples, so you have something that you can grasp. You could create political markets, for example. You could phrase the question, will Donald Trump be elected as a president in 2024? That would be a categorical market. In fact, a binary categorical market, because you just have the choice between yes and no. And you could phrase a question like, will agenda X be executed as presented at Y? Will also be a categorical market. You can create markets that predict something that happens on the stock. Like, will the price of super token be closer to a minimum or maximum value at a specific date? Which is a scalar market. You can also ask a question like, will super exchange list super token until a specific date, which will be a categorical market? Yes or no again. Then you can use it for journalism. For example, some data leaked about a new processor Intel is about to release. And now some people might be interested to know when it actually will be released. No? You can aggregate the information from the cloud by using a market in that case as well, by asking, will that processor be released closer to a minimum date, let's say January next year, or to a maximum date, let's say December next year, which would be scalar market. And basically the crowd would, by trading, adjust the probability. It will adjust the date when it actually thinks that it will occur. You could ask a question like, which party was responsible for a specific event? It would be a categorical market. You can use it in games and esports, which team will win a specific tournament, and categorical, or which guild will be the first one to subjugate the boss. It will also be a categorical market. And yeah, basically, you can use your imagination. There are so many possibilities. There's one example on the slide which actually doesn't work. It's the first example for organizations. So we have the question, will a specific decision increase a metric by at least 10% until a specific date? And this doesn't work, because if the answer is no, we won't implement the decision, and we can't measure the outcome, right? So this is an example of a market that you can't do. And yeah, and last example is, how much will the specific decision increase a metric until a specific date if we implement it. So the implementation is already planned, and then of course you will be able to measure the metric. Yeah. So far about examples. Now I'd like to dive into the actual protocol that we implemented. So it's gonna get a bit techy now. I hope I won't lose you here. Okay, so this is a component diagram excuse me, actually, can you take a look if the camera is still standing there? I think I placed it wrongly. Maybe you can stand it up again. It would do me a big favor if it has fallen down. I can't see it. It's right where this thingy is. Okay. Okay, so this is a component diagram of the pallets that we currently have in the runtime. And you see the yellow pallets are currently also used in the mainnet, and the gray pallets, they are basically excluded right now because they are still unstable. But they are already completely implemented. Just need some further auditing and code improvement. At the center, let me use that one. At the center, you have the prediction markets palette. It's basically responsible for offering means to spawn a market, to spawn a market, to be able to report the outcome, to resolve the market, to redeem your outcome tokens again for your rewards and stuff like that. And it's central because it uses essentially everything but the Liquidity palette. So let's stay on this right side here. It uses the swaps palette, which basically provides the pool functionality. That means that's where actually the trading happens. So there's the pool with the outcome assets and the base currency, and it's responsible for calculating the prices and the amounts of outcome tokens you get for an exchange. So there's the automated market maker that does the automated trading magic. Internally, it uses a constant product market maker, and it also uses our own basically extension of an existing algorithm, which we call Liquidity. I will dive into detail about those algorithms shortly. Then we have the liquidity mining palette. So the idea behind this you need somebody to provide liquidity to pool. for a constant product market maker. And that liquidity, so for providing liquidity, you will get some pool shares. And with liquidity mining, you will basically, depending on when you entered and how much liquidity you provided, you will mine a bit of Zeitgeist tokens. So you get incentivized to provide liquidity to those markets. And that's just one way of getting incentivized. On the left side, we have some more palettes. So market commons is just a common palette used for modifying the storage of markets. Not that interesting. But the three one above, they are palettes used for dispute resolution. So you might ask the question, what if the oracle reported the wrong outcome, right? We somehow need a way to dispute this and determine the correct outcome. And yeah, you can do this by using one of these different methods. When you create a market, you can select one. Authorized basically means you select somebody, or maybe in the future a collective, which is responsible for reporting the correct outcome. Simple disputes is a pretty simple algorithm where you have a number of consecutive disputes that arrive, and the last dispute will be the correct outcome. And then you have the court palette. So there everybody can apply as a juror in the court, and they can provide a stake. And then when a market is disputed that uses this mechanism, jurors from the court will be randomly selected to give their disputes to the market. And those who made wrong reports in the end will also be punished based on their stakes. This is the actual flow of a prediction market. So through which states does a prediction market go through? So you can create a market, and you can either say, I want to be my market should be advised. That means an advisory committee has to verify your market before it goes live. Or you can say, I want to be permissionless, so it starts immediately. Of course, if it starts immediately, there's much more responsibility. So your stake will be bigger to ensure that, basically to ensure that you don't do stupid stuff with the market, in short. Once either a market is started permissionless or a proposed market was confirmed by the advisory committee, it will become active. So that active market then can be traded. As I said, the trades will change the probability of the outcomes, which are directly associated to the prices. And eventually, when the market period has ended, a report can be done by the oracle, and then the market changes the state to a reported state. In that reported state, there's a specific amount of time, the dispute period, for the dispute mechanism to be able to dispute the outcome, as I just explained on the slide before. And lastly, a market is resolved after either the dispute period passed. After the dispute period passed, and then everybody can change their outcome tokens that they traded for a reward based on how well their prediction was. So at the core, we have the Zeitgeist swaps pool where the actual trading happens, and we have two different scoring rules, two different algorithms that determine how many assets you get for a trade, and they determine what the prices are for a trade. So we have, before I go into how they actually work, when you have an active market, you can deploy a pool. Then you can add liquidity. You get some shares as a liquidity provider to be eligible for rewards. And finally, you can trade the pool. We already went through that, just a minor recap. So when you trade the pool, the prices are determined by two rules that you can select when creating a market. One rule is a quite known rule in the DeFi space. It's the constant product scoring rule. And the constant product market maker basically uses this simple formula, which is the product of every balance normalized by a weight, if desired, is the constant value. You can also apply this to any pair of balances within the pool, and they will also be constant. And by that you can derive the actual amounts that you get for putting something in the pool, or that you have to give for taking something out of the pool. Yeah, and a constant just stays constant if you don't take out any fees or something. So this is like a reduced case. Here we see the constant product market maker as a graph. I guess most of you already are familiar with that. And you can see when I have more, so we have on the x-axis we have the quantity of asset B, and then on the y-axis we have the quantity of asset A. So when I want to sell A tokens, the more tokens of A are in the pool, the less tokens of B I get. There's always this relationship between the quantities of A and B that's constant, and that you can see graphically represented here by the two orthogonal lines that are drawn here. You can put the point anywhere and basically see how much you get. And then you can also use math to describe it and implement it in the protocol as we did. So there is another market maker that we are very excited to try out. It exists for like, I think, a bit more than half a year now. And we build it up on existing algorithms. We call it Liquidity. So I have to go a bit back in history here. So in 2002, Robin Hanson proposed an algorithm which is called logarithmic market scoring rule. And so instead of buying outcome assets out of pool, they are basically minted. They are printed when they are bought, and they are burned when they are sold again. And this was crafted especially for the prediction market case, and came along with some nice probabilities that were handy, like path independence and no arbitrage. Won't go into detail into that, but there was one major problem. So the potential loss of the automated market maker was potentially unbound, because it depended on what the volume of the markets were. There's a parameter in the formula B, an exogenous parameter, and the market operator had to manually apply that parameter to tweak it for different volumes. And that parameter was directly proportional to the additional liquidity that the market operators had to provide to ensure that in the worst case, all the traders can be paid out. So these are two things that are not that nice, right? We don't want to have unbounded losses, and we don't want to manually tweak a parameter all the time. This does not scale. So yeah, another paper was released, and I think it was in 2010 by Abraham Hartman and David Panek. And they have improved that algorithm in a way that two things. So first, the loss is bounded now. Because you have a maximum loss, it is the initial liquidity that's put in the pool to get it started by the market operator. That is the worst case loss, but usually they even shown it in the paper. It does run out equal zero loss or with a profit. That's one great thing, and another great thing, and I find this so beautiful, is that the algorithm is called liquidity sensitive logarithmic market scoring rule. The second feature is that it is liquidity sensitive. And that means a same size trade will actually affect the price differently depending on how many traders hold the outcome assets, right? So what does it mean? So I don't want to buy like 10 outcome assets and bump the price to one, to one. No, that's a bad example. So what does it do? I think I'll use an analogy here. So when you have, just imagine you have a small spring in your hand. And when you squeeze that spring, you apply some pressure. some force to squeeze that spring, right? When you have a thicker metal, when the spring is thicker, you need to apply much more force, much more pressure to get it squeezed down. And the algorithm does exactly that using mathematics. So just to draw the bridge now, the force that you apply on the spring is a fixed size rate. I want 10 of outcome asset A. And the thickness of the spring is basically how many liquidity exists in the market. That means the more outcome assets were bought by the traders, the thicker the spring gets and the more pressure you need to apply to move the spring. Consequently, the prices will change slower for a fixed size trade the more outcome assets were minted. And theoretically, you can also just start with zero liquidity, almost zero, let's say 0.00001, and the traders, by buying the outcome assets on each side and holding them, they are basically the liquidity providers, and you can go up to infinite liquidity and infinite sensitivity for the price changes for fixed volume trade, right? And this is so beautiful, perfect for our use case, so we decided let's go with it and improve it a bit. So what we added to this beautiful algorithm is that we also incorporated the history of the market in a sense that when, let's say, when there's like a spike of activity, then it also dampens that a bit by applying the fee correspondingly. This is the algorithm, don't worry, I won't go into detail here, but you might see that it's already a bit more complex than the constant product market maker. For those who are interested, the constant product market maker has a constant computational complexity, and this one has it's based on the amount of outcome assets that exist. So it's not that bad, it's fine, it's okay, we can live with that. Yeah, so you have this cost function here, and the cost function is, it basically tells you for the amount of outstanding outcome assets, so the amount of outcome assets that traders hold, which is Q, what is the total cost for that? So how much money was paid for that in essence? So all you have to do if you want to know how much B you get for A is to subtract C1 minus C2, which has the updated balances in the Q vector. Okay, I guess that's enough with the math. Let's move on. Here you can see the dampening effect I described with the spring. You have you can just see the prices based on how much quantity exists on for one balance in another. I don't want to describe it now. Please have a look at the graph. When you see the presentation slides in your own pace, it describes what it represents in the description. But yeah, you can see how the more of the outcome assets are basically traded and kept, the more the impact a fixed volume trade has is dampened. All right, that was rough, wasn't it? But we are done with it. Let's move on to the future prospect of Zeitgeist. So what we want to do next is we want to integrate additional currencies. Currently, you can just use Zeitgeist token as a base currency, but we also want to offer AUSD, which will happen now during next month. We will start the integration, and we will also want to use ERC20 tokens through Moonbeam and the Moonriver currency. Yeah, and there's an error. It's not called cross-chain message passing. It's called cross-consensus message passing. For the pedants, it's important. It's much more powerful than message passing. The combinatorial markets are another type of markets and outcomes we want to implement. I've already described them to you in the beginning. This is the conditional, the conditional outcomes. If A happens, then B will happen, or if A happens, metric will increase by that and that. And one of the most exciting things for us is Futarchy, and this is basically a novel governance mechanism that we want to base on the prediction markets. So to give you a quick example, you want to apply something in your organization, and you're not quite sure which path you should take. Then you propose some options. We could do A, we could do B, we could do C. And you propose some metrics that you want to change. So you have a specific metric, and you have specific decisions. And in the combinatorial market, you combine them into, if we go with B, we assume metric will change by that and that. In the end, when the markets resolve, you select the governance decision, A, B, or C, with the highest voted metric or the highest predicted metric and implement it. Then you implement it in your organization, and after time has passed, you measure the metric, and then you can pay out basically the predictions that were made in the first place. Yeah, I think that's essentially how I understand how Futarchy works, and we are pretty excited to implement that one. So how can you participate? We have a page, beta.zeitgeist.pm, a user-friendly UI, really. You can. Our front-end team did a great work there. You can just easily create markets, trade them, deploy some liquidity, stuff like that. We also have a faucet, but I'm not quite sure if we open it completely right now. Let me know if we did not. And as a developer, you can also utilize the power of prediction markets in your application. We provide a software development kit for that, which you can use to programmatically create prediction markets and do all the stuff with them I described. Finally, we have also a GraphQL query endpoint based on Substrate, so you can even get advanced insights about what your users like, maybe, or correlations in the prediction data that you might figure out. So yeah, thanks for now. Yeah, thanks. So I'm Harald Heckmann, lead blockchain engineer at Zeitgeist. You feel free to contact me at my email. Feel free to talk to me. Just want to say a huge shout out to the Zeitgeist team. I'm really having a great time with these guys, amazing people. I invite you to also check our open job offerings on Aegis.co, or if you have an idea how you could integrate, just let us know directly. And yeah, huge shout out to the Zeitgeist community. You're also amazing guys. And yeah, please, for further information, join our Discord, look at the documentation, or have a chat with us. Thanks a lot for your attention, guys.